Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will explain to you how to find out the interval of range for a given domain. Like if you're given an interval of domain, and then how do you find out the interval of corresponding range with that? So, one key advice here would be that you should always make a sketch of the equation so that you can clearly see the variation in the range. Like for example, I have to find out the range for an interval of -2 to 3 for a function 2x minus 1. One might think that it would be very easy and I can just plug in the value of domain as -2, I'll get the range, and I'll put the value of domain as 3 and I'll get the corresponding range, and I can easily find out the range would be from -5 to 5. That is something you can also see graphically here as well, that for the value of domain to be -2, I'm getting range as -5, and for the value of domain to be 3, I'm getting range as 5. So my interval of domain that's provided to me from -2 to 3, for that domain, I got myself a range from -5 till 5. So that's how I can find out the corresponding range. But it can get trickier in different situations. So it's again highly advisable that you do make a sketch, and I'll try and explain to you why. Like for example, you're given a function fx is equal to 7 minus x, and you have to find a range for x is greater than or equal to 2. You might plug in the value of x as 2 and you will get yourself the range as 5. And you might think for a moment that if x is greater than or equal to 2, then the range would be greater than or equal to 5. But when you will draw a graph, you will see that for an increasing x, the y or the range is decreasing. And that's something you can see by the graph, and hence you would be able to tell that the range value, and that's, I mean, you can just take any value bigger than 2 for a domain and plot it and then make a straight line. You know, this is an equation of a straight line. Well, still, if you do not want to sketch a graph, then you would have to look at it carefully and see that for a linear relationship, if gradient, which is the coefficient of x, is negative, then that means that there would be an inverse relationship. So for increasing x, there would be a decreasing y. For decreasing x, there would be an increasing y, if you do not want to sketch a graph in this situation. But it can also get trickier in other situations, like if you have this quadratic function and you have to find out the given range. If you do not make a graph, you can make a mistake of putting domain as -1, getting a range as 11, and putting a domain as 4 and getting range as 21, and identifying your interval of range to be from 11 to 21. But since it's a function, so there's a possibility that it initially decreases, then starts to increase again, or it initially increases and then it starts to decrease. And for those kind of situations, there might be a value outside this interval as well. Like I have put -1 to get 11, I put 4 to get 21, but I know that the function went below 11 as well. So that is something that I can clearly see by making a sketch. So I know this is a quadratic curve, and I know that it has a turning point 1 and 3. So I can plot that turning point, and I can see that the minimum value that I'm getting is 3, and the maximum value that I'm getting is 21. So my interval is going to be 3 till 21, with 3 being inclusive because obviously this is part of the function. The boundary values are not part of the function, so 21 is excluded. Even for this situation, you can have an alternate method, and the alternate method could be that you find out the turning point of the quadratic curve. And first you look at the x coordinate. If that x coordinate lies in the given interval, then you have to consider the turning point as well. And if it doesn't lie in the interval, then you can directly take the boundary values as your range. And you must recall that to get the x coordinate of the turning point, if you have this form, then the formula for x coordinate is -b upon 2a. And once you get the x coordinate, you can plug it back into the equation to get the y coordinate, to get the corresponding range value. And for this particular form, the turning point x coordinate is the alpha plus beta upon 2. That is the average of the two roots. And if you have a completed square form and you wish to find out the turning point, you equate the bracket to 0 to get the x coordinate, which will be h, and y coordinate will be k. Though you have these ways of figuring out the range, finding out the range, but it again is highly advisable to make sure that you don't make a mistake, that you sketch a graph and then identify the range. Let me discuss some examples with you. Like for example, I have been given a function and I have to find out the range of the function. So I know that if it's 3x minus 2, so there is no specific interval of domain that's given to me. So that means this is like a function that will be always increasing on one side and always decreasing on the other side. So that means your range is going to be all possible real values. So one way of writing it down is fx is from negative infinity to positive infinity, or you can also say that fx belongs to all real numbers. Even if you write it like this, that should also be correct. Similarly, if I've been given an interval from 2 to 5 and I have to find out the range, I can see it's a positive gradient. It will be increasing. I can plug in value of 2, which will be minimum value of range, and I can plug in value of 5, which would be maximum value of range. But if I make a sketch, I would have a very clear picture of what exactly is it that I'm doing. Similarly, if I know it's a gradient negative, I know it's going to be a sloping down line. So if it says from -1 till 2, so obviously this is -1 and this is 2, and I can get myself a corresponding range that lies from -15 is the minimum value and 9 is the maximum value. This is x is less than 4, so if I put x is 4, I know that this is a positive gradient. So if x is decreasing, the range would also be decreasing. So I can plug in that value of x and I can get a corresponding range, and I can identify that fx is less than 17. Otherwise, I can make a sketch and have a very clear picture of the interval of range. Mainly problem occurs in situations where you have these quadratic functions. So if you have a quadratic function which is x minus 3 whole square plus 5, and you just have to find out the range, you can see that its turning point is going to be 3 comma 5. You can plot the turning point. Coefficient of x squared is positive, so it should be a minimum turning point. And then you can see that this function keeps on increasing with a minimum value being 5. So your range is going to be greater than equal to 5. Similarly, if I will find out the turning point here, which is -2 and 7, and I know it's a maximum turning point since the coefficient of x squared is negative, so I know that it's going to be 7 or anything less than 7, so that is going to be the range. For this particular situation, if I find out the turning point which is coming out to be 1, I'll see that 1 does not lie in the interval. So that means that the turning point is not going to be affecting my range. I can directly find the range with the values 2 and 6. As you can see, it's a very clear picture of what happens once you make a sketch. As domain changes from 2 to 6, the value of range changes from 10 till 34. So that will be your interval of range. The problem would occur in situations where if this is the interval and you look at the turning point, the x coordinate by equating 2x plus 1 to 0 comes out to be negative 0.5, and negative 0.5 lies in this interval. So the turning point is part of the domain, so that means the function first goes down and then goes up. So if you find these extreme values, they will not be representative of the entire range. So you would have to consider the turning point as well. You can see that when x is negative half, y is 7. So minimum value is going to be 7 and maximum value is coming out to be 88. So you know that your range is going to lie from 7 till 88. Have a look at two more examples. I was given fx is 3x minus 1 whole square minus 5, and I was also told that x is greater than 2. So if I find the turning point, which is coming out to be 1 over 3, that is less than 2, so that means that is not the part of the interval. So you can see that if x is greater than 2, then your range is going to be greater than 20. So your range comes out to be greater than 20 in this case. Whereas if you look at this particular example where it says x is less than 1, so if I know x is less than 1, I can find out the corresponding range. So I know that if I consider x is less than 1, and I look at the turning point, which is coming out to be negative 1.5. So in less than 1, the negative 1.5 would be part of the domain. So that means I have to consider the turning point. So although if I put x as 1, I will be getting minus 22, but that is not what defines the range of the function. And if I look at the turning point, and that turning point is going to be negative 1.5 and 3, so I can see that the maximum value of this function is 3. So in fact, the range is not going to be determined by minus 22, it will be determined by 3, which is the maximum value. So hence the range of the function is going to be less than equal to 3. So guys, I hope this was a helpful video. If it did help, kindly please like and subscribe and share my channel.